expert. I'm not expert. But even though you are not expert, you can operate, you can scan. I'm not a surveyor, I'm not a geometric or geodetic engineer, but I can use the scanner like nobody business, right? So Ben will start a scan so you can see the screen. Maybe a bit lag because of the cable, but it's actually a very smooth on the tablet. So what Ben will choose is indoor mode or 2-minute mode or 4-minute mode. It's all up to you. We have a table to show you 2-minute, 4-minute, 6-minute, what is the density of the point cloud. I didn't put in the slide, sorry about that, but there's meaning about it. So Ben already press scan. So what happened now is doing automatic calibration. 25-second automatic calibration. So the light here actually telling you is actually doing calibration. Initializing scan. So now it actually starts scanning, right? So the time to scan is 50 seconds for one station. 50 seconds. Right? So now I do calibration. I think when it scan is green color. Not yet. Not too fast. So this is the user interface of the software. So as I said, if you know how to use Android, Apple iPhone, Android, you can control the laser scanner. So right now it starts scanning, as you can see, it starts turning. It will give you indicator how long more you want to scan. Seconds, 45, 48, 10. Alright, now we finished the first station scan. So what does it tell you after your first station scan? So the scan data will be downloading into the tablet, as I said, right? Because everything is stored on the tablet. And the tablet and the software also assists in auto registration. So when you download it, you already can move the laser scanner to the second station. This saves you time if you want to scan 100 stations, right? You can already move to the second station. So while downloading, we actually can scan second station already, right? So what happened now is you choose again, you can change the mode. From station to station, you can change the mode, right? So it really depends. But normally from station to station we don't change, right? We already set. So now do it again. Calibration. 25 seconds. After calibration, scan. So it also show you the battery, the storage, right? Wi-Fi connectivity, right? How strong is the connection between the scanner and the tablet? So what I want to show you after the 2 scan, we talk about auto registration, right? So what I want to do the software and adjust itself to do auto registration. From 2 stations become 1 3D point cloud, right? So I will show you on the tablet as well. So you can also choose whether you want images on your scan. If you don't want images, you can turn it off. So you only do scanning. If you want images, it will take scanning and image. So you can choose, right? So flexibility, simplify everything. So Ben is choosing a more longer scan period. So this one will show you can adjust the mode, right? So you actually finish scanning, it will download the scan. It's probably take another 1.5 minutes to download it. But what is important, I want to show you what I say, right? Auto registration. I want to show you how the 2 stations join together in the software. So station 1, you have downloading station 2, wait for it. Once the station 2 come in, they will join together to station 1. So this is the auto registration that we talk about, right? So you already can play around with the point cloud, as I say, do measurement, right? Clip box, right? Whatever you want to do while waiting for station 2 to come in. You also already can maneuver around. Clip box, you want top view or side view, all those already can be looked at from the station 1 point cloud. The file is a little bit bigger on station 2 because we choose a more density, higher density mode. So the download time probably take around 1 minute to download. So then what else we can show before we move to station 2 or the registration? Yeah, we can measure the height of the ceiling to the floor already, right? By using the point cloud. We also can measure it in a picture as well, right? Not only the point cloud. Yeah, this is the grayscale images of point cloud, right? So the other thing about the X7, X9 is if you are scanning in a very noisy environment. What is noisy environment? There's no human, there's no car, there's no movement. So in the office, you can actually remove all the human, remove all the car, remove all the unwanted data from your point cloud, right? So you have a very nice representation of the environment that you want. So 2 minutes, give me 2 minutes, I will show you so-called the magic, I call it, right? Auto registration. So when I talk about auto registration in Trimble, it is 100% registered. So because we are not using point-to-point registration, we actually do the registration from the point to some plane that we have created the technology in our software. So we are very, very confident in the registration from the field software. So almost coming. Give me 1 more minute. Then what else we can show? So another thing we can show you is if you are doing scanning in one particular area, you want to have a very detailed. For example, you want to have this detail, right? You can select the area, this particular area, to do a more dense scan, right? So later we will show you, right? I think the Wi-Fi connection is a bit slow here, right? But so it will take longer than normal. So if you have 5G environment, I think definitely they will speed up the process of downloading the images as well. So from a picture, you already can do a lot of things, label, annotation, as I mentioned. Take a photo of the area, make a remark. The pillar is slanted, the pillar is cracking, the pillar is deformed. So you can make a remark, tell your architect, tell your engineer back in the office, right? So all this is capable. So Ben just now just already do a measurement. There's an immediate, all these measurement can be documented, traceable, digitalized. So it's not manual anymore. So everything you do on the scanner can be digitalized, can be shared, can be traced. Alright, so I think Ben is trying to change to his handphone or whatever so that the Wi-Fi is faster to download the data. 82. Alright. So what else, Ben? Miss out on the scan? I don't know. So yeah, Ben just make a annotation, right? Pillar. So as I say, all these annotation will follow back to your architecture software environment. Right? The Wi-Fi is a bit slow, right? You want to connect to your handphone or something? Directly to the scanner. Okay. Sorry about that, a little bit because of the Wi-Fi. I think probably there's a means you check the flatness. So when do you check the flatness? want to watch this because I want to show you the registration. So when do you check the flanders? When you have pour a cement on the floor, you want to see whether it's flat or not. You scan immediately compared to a plane, and it will show you the heat map, which area is lower than the specification, the tolerance. So the tolerance can be set by you, whether it's 2 millimeter, 3 millimeter. So, alright, so almost coming in. Then go back to the point cloud, just show the registration. So almost coming in. You don't want to miss the timing. So now we have one, right? Station 1, Station 2 coming in. Green and blue. They do registration to 1. It will move it to 1, right? This is the auto registration function inside our software, right? So on and so forth. You continue scan, third station, fourth station. This is what I say, right? You have the station 1, you can see where is station 2 because there's a IMU, and also there's our software that remember your orientation when you move. So everybody see the auto registration? Yes? No? No? Need to do it again? No. Okay. So what we want to show you next is to select the area. You already scanned 2 stations, but maybe you want to have more dense, more clear, more dense point cloud or particular area. So then can we navigate to the rebar there? So how we navigate? We have a camera, right? Everybody remember there's a camera on board. So we will navigate from the camera or the point cloud, select the area to do another scan which is more high quality. So this will take less than how many minutes? Estimate minute of the area that you selected, 1 minute. So when can we hit scan? Starting 1 minute. So again, this will register immediately as well, right? Yes. Expert, no. So after you scan the area that you choose, immediately it will register again back to the first and second station, right? So this is X line, right? X line, remember the range is up to 150 meters. What else we can show them while we are waiting, right? Right, this is the station, right? We move one station to another station. So the 2 different colors is representing the 2 different stations, right? Green is the first station, or blue is the first station, green, right? Alright, I think it's scanning pretty fast, right? Another 50 seconds. So laser scanning technology is taking million points, right? As I say, your data can be very big. But in our technology, we actually compress the file, become very small. Why do we compress? Because after you scan 50 stations, you want to export, you want to email, you want to upload to cloud, so that the compressed file can be uploaded faster. When your architect back in your office want to use the point cloud, it is faster also when the file size is smaller. So in our software, we actually compress the file to a smaller size. Right? So, done. Point cloud, area scan, done. Downloading. So, do we want to share the registration again? Downloading. Yeah. So I will show you the registration from the area that we select. After that, I will move to show you the laser pointer, right? As I talk about laser pointer. already registered to the first and second. Alright? So that is done. So the next one we're going to show is laser pointer. Okay? So remember what the usage of laser pointer? Georeferencing. If you have a target, you have a control point, outdoor, use the laser to shoot to the target or control point. You georeference your laser. Right? So we show you how the laser pointer, where is the laser pointer, the area to point, so that you can see the laser pointer maybe in front in the dark area. Just assuming you have, at the corner of this pillar is your control point. So you can maneuver using the tablet, right? To the corner. So use the laser pointer, you can see the light. Can you see the light? Everybody? You see? The light? Right? So there's the laser pointer to georeference your data. Right? Go ahead. It's me, right? So alright, I think we have done point, precision point, key the detail, take a picture of area because every partition look the same. So to the area environment, the area can be georeference, right? Alright, then want to choose a more significant area to shoot. So you choose the area in front of this rebar. Thank you very much, gentlemen. So you choose the area right in front and you do a georeference. Measuring now. So the next thing we want to show you is how can you do inspection, QA/QC, right? So, right, scan point, created, input the information, take photo. So everything is done on the tablet. So you can see how easy interactive is the software to control the scanner. You can sit down there and to operate the scanner. Don't worry about it. So yeah, station 1, station 2, your point here. Everything is recorded. So when are we ready for the next one? Alright, can we just I will move the laser scanner to the middle to show you how we do inspection, QA/QC, compared to plane, compared to your design model as well. Right? Because I don't want to say it, but I want you to see it actually. Right? So let me move the laser scanner. Auto leveling, right? You don't need to worry if it's started yet, right? Because there's no level compensator inside. So I just leave it like this. Actually, it's very simple. Don't worry about it, right? Because the green indicator is telling you good, no problem, you can go ahead and scan. So all the right thing is actually information. Green means no problem, go ahead and scan. Right? So then, once you're ready, let's show it. So in Singapore, I think anyone of you using Excel next time? One, two, oh. Maybe hear from him. What is good, what is bad? You want to share something? Like what is good, what is bad?
It just for the cover reason. What every thing becomes digital, the scanning outside. Actually, it's covering on now.
Understand? Because you are using X7, right? Yeah. So he's using X7. What he's saying is outdoor environment, the range is not enough. I admit because it's only 80 meter range, right? So if you want to scan outdoor, X9, longer range, right? So other than that, anything is good. Tell me one thing is good.
Outdoor registration. Also good.
He say outdoor registration is very good. So he's a user, he's not an actor, right? I don't have money to pay him, yeah? Alright, so again, we do calibration because we want to scan the environment. After I scan the environment, how we check the flatness. Right? So we want to show you that as well. So how long you been using X7? 2 years?
Yeah.
2 years. 2 years, ladies and gentlemen. Any problem with the scanner?
Actually, it's
2 years. Nothing happened. Right? No. It's not actor here. Huh? 2 years. Good. Thank you very much, sir, supporting Trimble. But buy X9, one-wheel range, right? So, Ben already scanned, downloading now, 60%, 10%. So what I want to show you is
but it's
flatness
okay.
check.
We just covering
In
rates not
immediately.
because it's scanning only.
Show you two things,
Active meter,
flatness
every 5
check,
meter my
and
one
how you
scanner.
bring your
So
3D design data
every
into
fully
the
captured
scan
every 5
compared to
meter.
your 3D data.
Using for S-Bit? Sorry? Using for S-Bit.
Who else is thinking of investing in laser
Actually, it's
scanner?
using for the cars, purpose of it.
Nobody?
We are pick
You're
up all
gonna
the
give
details.
50% discount, you know? Anybody? Nobody here? Free cam, come to me later. I give you. Sure. Come to me. So, if you are thinking investing lasers outdated, you need to upload a new firmware, or something wrong with the camera, or something wrong with the laser, then you need to send back to us. If we can remotely revive it, we will do remotely. So you don't need to send back to us. No need to have downtime. No money that we're going to charge you, right? So there is the benefit of laser scanner. So what Ben is going to do is to show the flatness check, Ben? Yes. Okay. So why flatness check is important? When you cement, you pour the cement before it dry, you want to quickly fill out the area which is not confirmed to the specification, whether it's 2 millimeter or 3 millimeter, or even 1 centimeter. So all these parameters you can set yourself. If the tolerance is 5 centimeter, 5 millimeter, flatness cannot be 5 centimeter, right? 5 millimeter you can set. Anything beyond 5 millimeter become red color, right? Anything within 5 millimeter is all blue color. So we will show you on the software. So Ben, okay, have we shown?
So just to explain this portion, what I did is I selected a point on the ground and use that as a reference elevation. And then from here, I can set a tolerance of, for example, 5 cm. So here it's going to show me using this scale based on the reference elevation that I selected of 1.354. It's going to show me plus and minus 0.5 mm. So from here, one look at the floor, you can see which area is level and which area is high. Okay? So you can see the red areas are up to 5 cm, 5 cm above my reference elevation, and blue is 5 cm below the reference elevation. So all these can be configured here. I can choose it what's my reference elevation as well as the range. The range is the tolerance of plus and minus portion.
Alright, so this floor flatness check. So I think the next thing that we want to show you is how you're going to bring in your 3D design data compared to the scan point cloud. Alright, so because we don't have a design model of MPS exhibition, so but we are just show you the step, how you do it, right? I think I kind of overrun a lot, but it's good. I want to show you the capability of the X7 and X9. So, Ben, you will check me what is this? I don't know.
So this is an example of how we can bring in our design model. In this case, it's a SketchUp model actually. We can import it right into our tablet and we can bring it to the field. So for example, for a construction project or for any project that you already have the design element, design model, we we can preload it into our scanner and we can bring it to the site. And from there, we can actually create points, reference points directly from the model, and we can use those points for resection setup, where we take our orientation of our scanner based on the points from the model. So we can do a resection based on the model, and from there we will be already in the same coordinate system as the model, and we will be, basically our orientation of our scanner will be located within the model. From there we can do our scans. So whenever we do our data capture of the scans, it will immediately be overlaid over our model in the field. And that's when we can do our inspections, comparisons between the point cloud and the model for QA/QC checks, and also for flatness checks or any other kind of point cloud and model inspections.
Alright, I think this is the end of my demo, but don't go away. Thank you, Ben, for the very good expertise that you have to do the laser scanning. The next session is actually TBC. So what is TBC? Who is using TBC in the room? Trimble Business Center? Okay, good. Thank you very much. So TBC, I don't want to take this over his presentation, but we actually build in a lot of AI capability, artificial intelligence capability in TBC. So Ben will showcasing the capability of the TBC in just a minute. So let's swap the computer.